Hello, young ones. So, quiz 5-1 was a bit of a nightmare since you don't get retakes, so I'm going to go over it. Okay, so number one says sketch a reaction coordinate for endothermic and label delta H. So, these are our reactants, that's our product. Okay, so this is E delta H. Most of you got that, so I'm not going to spend any more time on that. All right, so number two says, use the following information to answer the questions below. So which of the substances needs to absorb the most energy in order to increase its temperature by 1 Kelvin? So remember, specific heat is the amount of energy that something needs to get to raise its temperature. So whichever has the lowest specific heat will experience the greatest temperature change. So when I look here, I see that gold has the lowest specific heat, so it will experience... Oh wait, which needs to absorb the most energy? I'm sorry, I got it backwards. That would heat up the fastest, so the one that needs to absorb the most energy would be water. And then B says, on absorbing a given amount of heat, which would experience the largest temperature change? I just explained that one, which is gold. All right, so next says, how much energy is needed to increase the temperature of 2 kilograms of gold by 5 Kelvin? So remember, you got to be careful with your units. Because we're using kilograms, the unit will be kilojoules. Okay, so we should know that we're going to use Q equals M times C times delta T. We are told that the mass is 2 kilograms times the specific heat for gold, which is 130 joules per kilogram Kelvin. It's also kilojoules per kilogram Kelvin. That's a little bit of a mistake there. Times the temperature change, which was 5. 5 times 2 is 10, times 130 is 1,300 kilojoules. For the most part, the errors that were made based on units, but I didn't take any points off for using the wrong unit, just for giving me the wrong number. Of course, if you said 1.3, that would be a megajoule, so it didn't count. Okay, so number 3. We're kind of out of focus here. Let's see what we can do. I guess that's as good as it's going to get. All right, it says calculate the specific heat of a metal if 11 grams of the metal was dropped into a calorimeter that contained 50 grams of water at 25.8 degrees C. The metal had been in a hot water bath of 100 degrees C. So that is essentially the temperature of the metal because of heat flow. The final temperature in the calorimeter was 26.8. So just imagine what happens. We got this water, 11 grams of it. It's at 50 grams of water at 25.8 Celsius. So the metal is losing heat. There's two things changing temperature, the water and the metal. So the equation we're going to use is heat lost equals heat gained. And since heat is mc delta T, I can say that the heat gained is equal to the heat lost in the other substance. All right, so let's see what we got here. First of all, since the metal is going from 100 to 26.8, that means it lost heat. So this side of the equation will be for our metal, and this side of the equation will be for our water. So let's go ahead and plug in. All right, so the mass of water is 50.0 grams times the specific heat of water, which we know is 4.18, times the temperature change, which is final minus initial. So the water ended at 26.8, but started at 25.8. All right, then we get the other sign. Don't forget the negative sign. So we had 11.00 grams of the metal times its specific heat, which is what we are trying to find here, times the temperature change. Well, it ultimately went to 26.8. And it started at 100. All right, so algebra. When you solve, your answer should be 0.260 joules per gram per degree Celsius. Now you may wonder why I did 260. Sig figs. 4 sig figs. Oop, our temps have 3 sig figs, so I rounded the answer to 3 sig figs. That question itself was not too problematic. All right, here's where the nightmare happened. All right, so just so you know, number 4 and 5 are exactly what we did in our lab. Sorry, I'm making a video. The quiz in HL didn't go so well, so I'm making a video explaining it. All right, so number 4, and by the way, we did exactly this thing in the lab. We took 2 grams of calcium chloride and mixed it in a mass of water. All right, so we got 2 grams of calcium chloride and 100 grams of water. The initial temperature of the water was 25. Final temperature was 32.8. Assuming specific heat is the same as that of water, calculate the enthalpy change of this process per mole of calcium chloride. Okie dokie, so we got to remember that when we're calculating a delta H for any reaction, it's going to be the heat change over the number of moles of either whatever the limiting reactant is or the salt that we are starting with. Don't forget, it's got to be negative. Okay, so let's first calculate Q. Now remember, when you put the salt in the water, it's the water that's experiencing the temperature change. So when we're calculating Q, it's just the mass of water that we plug in. Now, we're not asked for a particular unit, so we could do joules per mole or kilojoules per mole. I'll just keep it at grams and do joules per mole, and then we'll convert at the end. All right, so mass of water times the specific heat of water, which is 4.18, times the temperature change, which was final temperature 32.8, minus initial temperature, which was at 25.0. So I don't have this, it's like 3,200 something. I'm gonna find my calculator. Where the heck did I put it? Oh, it's right here behind my lunchbox. Okay, so putting this into yonder calculator, it's gonna be 100 times 4.18, 7.8 times 7.8, right? 25, 32 would be 7.8. Yeah, I think 7.8. Let's just go with it. All right, so I get 3,260.4. 3,260.4, but to 3 sig figs, that's going to be 3,260 joules. Be aware of your units. Now for the N bit, that's the number of moles of the salt. So I had 2 moles of calcium chloride. To calculate the number of moles, you divide by the molar mass. So the molar mass of calcium chloride, calcium is 40.08 plus chlorine 35.45 times 2. So that's 110.98 grams. So 2 divided by answer gives me 0.018 moles, 0.018 moles. So now to calculate delta H, it's going to be negative Q, which is 3,260 divided by N, which is 0.018. When we do the math, negative 3260 divided by 0.018, I get negative 1811111, 2 sig figs there, so it's going to be negative 180,000 joules per mole, which if you did it in kilojoules would be negative 180 kilojoules per mole. All right, just exactly what we did in the lab. Huzzah. All right, finally, 1 cubic decimeter, which is 1 liter of 2.5 molar HCl, was neutralized by 1.00 cubic decimeters of 2.5 molar sodium hydroxide. I can pause. What's up, Mr. Rhodes?
Sorry.
It's okay.
This is easier than the blue day.
No problem, yeah. All right, so both of the acid and the base started at 22.3 Celsius. After mixing them together, the temperature of the mixture went up to 31.7. Blah, 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 blah. Calculate the standard enthalpy change for this reaction. So the first thing I gotta look at is the amount to determine what's limiting. So volume times concentration gives me moles. So 1 liter times 2.5 moles per liter gives me 2.5 moles of HCl. Same thing for NaOH. Remember, if they're equal, then nothing is limiting. Just choose one. Okay, so remember, if the density is the same of water, remember, water is 1 gram per milliliter. That means it's 1,000 grams per cubic decimeter. So when I mix the two solutions together, I have all that water combined, right in there. So I have 1 liter from one, 1 liter from another, for a grand total of 2 liters of solution. A lot of you guys tried to overthink this, and you were like calculating the number of moles, doing a stoich, blah 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 blah. Just add the volumes. All right, so 2 kilograms times the specific heat of water, which is 4.18, times the temperature change, which was final 31.7 minus initial 22.3. When we do this, we're going to be calculating Q. So 2 times 4.18 times 31.7 minus 22.3. Presto changeo. I get 78.6. 3 sig figs all around, so 78.6 kilojoules. I'm almost done. I'm just making a video. Remember, delta H is negative Q divided by N. So negative 78.6. 1 times 2.5 means I have 2.50 moles. So negative 78.6, negative answer, divided by 2.5 gives me negative 31.4. Negative 31.4 kilojoules per mole. I just did 2.5 because they're both equal, so we use blah, blah, blah. Anyhow, kids, if you didn't do good on this quiz, which is about 2/3 of you, then please watch this video, and happy reviewing.